morning. This is Neve Goswami. It's 10 a.m. in the clock, and now it's time for the very interesting session, which is all about virtual labs. This session you're watching at PM eVidya channel number 6 to 12, and of course on our official YouTube channels, which are NCERT Official and NCERT PM eVidya class 6 to 12. Today we bring class 10th subject science. The topic that we're going to cover is demonstration of simulation on electromagnetic induction. The same one is flashing on your screen, and to elaborate this topic I'm having as an expert in the studio Dr. Uma D. Sharma, who is an academic consultant at CIET NCERT New Delhi. Ma'am, a very warm welcome.
Thank you.
Okay, इस सेशन को शुरू करने से पहले बात कर लेते हैं वर्चुअल लैब्स की. वर्चुअल लैब जो हम आपके लिए हर हफ्ते ये सेशन लेकर आते हैं, अब तक आपका परिचय हो ही चुका होगा कि वर्चुअल लैब्स हैं क्या, लेकिन एक बार आपको फिर से ब्रीफ दे देते हैं कि आखिर वर्चुअल लैब्स असल में क्या है. जब हम बात कर when we talk about virtual labs, so that is an online platform where you can proceed the experiments through simulation, and it is absolutely convenient for students and researchers, which gives you the freedom to do experiments with the help of a computer or any other portable device. And the key features are that you can practice on this anytime or at any moment. And the main feature of this is that you don't need the equipments or a real lab space or some dedicated lab space. So it's absolutely convenient at your part. Okay, so before we begin this session, I just want to tell you one important information, and that is if you have any question regarding the session, you can directly ask us via calling us on a phone number which is flashing on your screen, which is 8800440559. And if you have any feedback, any suggestion regarding the session which you want to send us, so you can write down our mail ID, which is diksha.training @ciet.nic.in. And as I've mentioned, our YouTube channels at the beginning of the session, so if you're watching us through our YouTube channel, so you can directly ask your questions in the live chat box, as that facility is available there. So without any further delay, I think it's time to start the session with our expert and our resource person too, Dr. Uma D. Sharma. Ma'am, first that I want to know from you that what we are going to discuss in today's session, what we are going to learn, and just give a brief of today's session, that what we are going to experiment in today's session. Yeah.
Today is a very interesting experiment we are going through. This is a class 10th experiment, that is a simulation of or we can say the demonstration of simulation of electromagnetic induction. Just we need to understand what is the phenomena of electromagnetic induction is. It is a really important concept because in daily life or in daily utility, we can see in motors, generator, this phenomena is there. So what is exactly electromagnetic induction? See, whenever there is a change in the magnetic flux, okay, so we can generate the electricity. So if I go to the some history, like 200 years back, electricity and magnetism both are separate entity. Both are like electricity is separate concept is there, magnetism is separate concept there. Recently in 1831, this Michael Faraday has done a various experiment, and he comes through the this concept of electromagnetic induction. What he has done, he has changed this. He has taken a simple bar magnet and a simple coil of copper wire, and through the copper wire he has connected this galvanometer. So he has just make a to and fro movement with this bar magnet, and what he has observed, that the galvanometer is showing deflection. That what is the inference that? That means if there is a change in the magnetic flux, then electricity can be generated. So again here we can see that the concept of conservation of energy is there. Like when the mechanical energy is changing, what we are doing the work on bar magnet, we are changing its position. So whenever there is a relative change in motion of bar magnet or the coil, what happens? The electricity is generated. So this is the major discovery, and then it is related that both magnetism and electricity both are interrelated.
Indeed, a very important discovery by Faraday in 1831, where he just put all these two things together, a magnet and a copper coil. Ma'am, just want to know the use of this thing in our daily routine, like what's the application of this thing? Would you be able to elaborate that?
Like if you see the motor, simple fan, how fan are working, or electromagnetic induction, or inductor we are using, the inductions we are using at home. So, so they are using this concept of electromagnetic induction. Simply the current is passes through this coil, and in this case the vice versa thing happens. And this rate of change of magnetic field creates the heat. So inductor is one of the example. Similarly in generator, so without like generator we can how the AC current is produced. So AC current is also produced because of there is a continuous change in the motion of this coil of wire, and the changing magnetic flux produces this electric current. So the base concept is same, and all are using this electromagnetic induction process and this phenomena, and generator is one of the example, motor is one of the example.
Absolutely. AC is alternate current, ma'am, but today's session is all about that. We are going to see the simulation of on electromagnetic induction.
So
where we are going to find these virtual labs. This is this is what we have told our viewers a lot of times, but I just want you to start from the scratch. Where do we find these virtual labs, and what are the other resources that we actually find on these virtual labs?
So I will show you. We just go to the diksha.gov.in, and you will see a very new portal of Diksha now. So see, I will just showcase your new portal here. See, initially it is a textbook, video, interactive contents. So entirely the new platform is there. Browse by subject is there. You can directly browse by the subject. Suppose you want to learn about science or mathematics or social science, directly you can click these tabs to go through it. And this is for view all subjects. Then browse by grade, we can browse this Diksha by grade also. So we are talking about this virtual lab. So this virtual lab is the focus area of one of the focus areas of Diksha. So how you can go? Simply click on the virtual lab tab. So we can go to the this well-known page of virtual labs, where we can see the from grade 6 to grade 12th all the experiments are available in both English and Hindi medium. So we are going, this is a class 10th experiment of science, that is electromagnetic induction. So we go to this is a I have already opened this is a 56th number. So you can scroll it down, and this electromagnetic induction. So there are two resources are there, experiment PDF is there, and this learning resource is there. Under learning resources you will find simulation electromagnetic induction, and under this experiment PDF we will find that the same experimental PDF which we are of the lab manual. So I have already opened it. So let's go directly to this. This is the experiment PDF. So what is this? To study the phenomena of electromagnetic induction. So as I discussed you, this phenomena of electromagnetic induction is nothing but the existence of this induced current, or we can say the EMF in the circuit, okay, which is placed in this region, and whenever there is a change in this magnetic field. So time, the first condition should be time varying magnetic field. If it is not changing with respect to time, then no current will produced. Means if the case is that this bar magnet is at the stationary position and this coil is also not moving, in that case no change in the magnetic field is there. So no change in this galvanometer is also found. That means no current is produced. So this is the first condition of this electromagnetic induction. So then by the name itself we can say that magnetic field. See, there are two scenarios. You can change the magnetic field either by two steps, because all this experiment is done by the Faraday. In the first case, what he has done, he has changed this this bar magnet, okay, to and fro movement. So again, when it is going back and so to and fro movement, there is a change in the magnetic flux. The galvanometer is showing deflection. In second case, what he has done, he has kept this bar magnet at rest position and moved this coil to and fro position. Okay. So again we can see there is a time varying change, relative motion of the coil is there. So magnetic flux is changing. So again the galvanometer is showing deflection. So thus in both the cases we can see that the effect of moving a magnet in a coil connected to the galvanometer, in both the cases in coil this electromagnetic induction phenomena is taking place. Okay, and in the third scenario, he has, see, I am showing you this image. There he has taken two coils.
Okay.
Okay, one is connected with the battery, and one is connected with the galvanometer, and this here we have connected a varying. No, this is not switch. This is a rheostat. This is rheostat, and K is the switch. So by the rheostat, what we are doing, we are varying this current. So by varying the current, what we are doing? By varying the current, the change in the magnetic field is taking place, and hence the galvanometer is showing deflection.
Reading.
If we are not varying this, so no change in the current. So the inference is that in all this case, the conclusion we found that then we will go back to the directly to this practical. We observed that the electric induced current is produced when there is a relative change in the coil or the bar magnet. Okay. So we will go to the experiment. So this is a simulation part.
Okay.
Okay. Let's start it. This is to study the phenomena of electromagnetic induction. Let's go. So this is the picture this is the first page, you will get it over here. On the left hand side, you will see the instructions. Click on any one of the magnet from the bar magnet section. Okay. See here, two bar magnets we have taken, south and north, north and south, this thing. Okay. As we have clicked on it, so see, when I am doing this to and fro motion, so here the galvanometer is showing the deflection. Also, if you observe one thing, when I am moving it towards the coil, it is moving towards the right hand side. When I am moving it away from the coil, it is moving on the left hand side, because this is because the change in the direction of the current. Okay. Because when you are moving in this direction, the current is flowing in the one direction. In this direction, the current is flowing in the opposite direction. So that's why the deflection in the different opposite direction is there. Okay. Now the same thing we can do it. One more thing. It is also observed that when I increase the number of turns in the coil, then the intensity of this magnetic field increases. Okay, the current in the coil will produce more.
Okay.
Let's see. Suppose I have taken the 500 turns. First case, 500 turns. Okay, number of turns are 500. Because if I go deeper into this, the formula for electromotive force, which is actually developed while the change in the magnetic flux, is E equals to minus d phi upon dt, or let me show you over here on this paper. I will show you tabletop.
Okay.
E equals to minus n d phi upon dt. Okay, this is the formula for this is the formula for the induced EMF which is developed. E equals to minus n d phi upon dt, where n is the number of turns and phi is the change in the magnetic flux and E is the electromotive force. Because of this only the galvanometer is showing deflection. Okay. So this is the formula. So as I am like in the 500 turns, you will see it is moving till only 10 only. Okay. Let's do for the 750. As I am moving, it moves towards the 20. So yes, what we are observing, or suppose for the 1000 turns, again doing this thing, it is moving towards the 30. That means the intensity of current is increased as the number of turns in the coil is increasing. Okay. Now here is one observation table is also included. So we can repeat this experiment one by one, like pole direction, but the pole direction I have taken south pole. I have taken the south pole. So I will write south. Number of turns I have taken 500. I will write 500 over here.
Okay.
And the galvanometer is, let's see, it is showing 10 division. So I will write 10. So tick tick. All the observation I have taken is correct. I can add one more row to for the just see this. Pole direction is south only. South only, south. Number of turns I have increased 750 now. And let's see, it is showing 20. Okay. So this is the case when the pole direction is south. We can repeat the same experiment when I have taken the pole direction north. Now. So in the case of north, let's add one more row. I will write north over here. okay, north over here. Then again I will do the same experiment. Here I have taken how much turns? 500 only. So I will write 500 and it is showing 10 only. So again one more inference. These are the different scenario. Let me check. 10 only. But here I will write minus 10 because direction is opposite.
Due to north pole.
Not due to north pole, because the direction of bar magnet is changed and hence the direction of current is changed.
True.
So that's why minus 10. It is moving towards opposite direction. You will see here it is moving in the just vice versa direction. So hence I have to write minus 10 over here.
Got
so it is so these are all the conditions which Faraday has done while doing this experiment by taking simple one galvanometer and this coil and the bar magnet, one permanent magnet, okay, and the various scenario he has checked, like by relative motion. Here we have considered only one kind of motion, that we are able to move bar magnet only, not coil. Otherwise in the vice versa case the current is produced. So we can complete this experiment. Now on the right hand side we can see first is theory, which I have already explained with the help of that PDF file. That's why I have not opened. This is a procedure to do how to do this entire simulation. Here is the animation of this entire experiment is there, and at the end we will get the Viva. Okay. So this is the to analyze about what is electromagnetic induction phenomena, and how to I have demonstrated it through this simulation part, what exactly electromagnetic induction is. And we can see that Michael Faraday in 1831 proved this with a multiple experiment that electricity could be generated from magnetism. So let's
ma'am, after the simulation, do we have, as you have mentioned that we have Viva thing as well, so can we proceed towards that, because it's very interesting to see that how the children, those who are watching us right now, will evaluate themselves.
Yes, definitely. So here one more thing is there, that is Viva voice. Okay. So already there is a quiz kind of Viva is there here. Certain instructions are given. The quiz will start by clicking OK. You will get 1 marks for correct answer. Okay. No negative marking is there. So it is a like fun when the learner is doing this kind of quiz. So they have a feeling of competition also. So teacher can play this quiz in the class also. To understand, to know about the competency of a child. So name the rule of to find the direction of current induced in a coil due to the rotation in the magnetic field. So here it is a, let's randomly I am
Fleming's right hand
Fleming's left hand rule, right hand rule. Let's see. Submit. Yes, Fleming's right hand rule, correct. Next, the phenomena of electromagnetic induction is, just we have understood, producing induced current in the coil. Submit, correct answer. So let's check for the, if I put the wrong answer, what will happen next?
Okay.
Randomly, though the answer is electric current. So let's do for the magnetic flux.
Okay. Submit.
So submit. So wrong answer.
Okay.
So you will get this wrong answer. So next, when the north pole of the bar magnet is pushed toward the coil, the direction of deflection of galvanometer needle gives the direction of
flow of current.
Current. Submit. So then finish. Acha, yes. So see, this kind of scorecard will also get 3 out of 4, correct answer 3, wrong answer 0, partial attempt 1, unattempted 0. So 1 minute 25 seconds. So when this kind of quiz is conducted in a class of 40 or 50 students, okay, so by seeing this they will get a very, they will have a very proud feeling ki I have completed this entire quiz in 30 seconds or 1 minute or whatever, or all the questions are correct, and they will get this kind of cup is there. So this is a very good feature which I found very interactive in this case.
Ma'am, absolutely. The feature, the concept of virtual lab, it's interesting itself because this gives you a freedom, as we mentioned earlier at the earlier of this session, and most important that how conveniently we record those readings and we got the tick mark. We have this assessment part as well, the Viva voice. Ma'am, but most important that do we have other learning materials or suggestions from the Diksha itself, like how we can enhance our knowledge on the particular topic?
For the particular topic, they can search. Okay, in Diksha, if yes, you can. There is a one feature is there. Ask Diksha is also there. Okay, so suppose for particular feature you want to understand. Let me go. This Ask Diksha feature is there.
Okay.
Okay. So suppose for this electromagnetic induction, you want to understand more about this. What is this? What is more about electromagnetic induction? This particular topic. So we can simply type this. Let me wait. I think it is hang. Oh, it has taken that question. Suppose, for example, give me the summary of force and laws of motion chapter. So here the entire the detailed version of that topic is there. What is momentum? What is second law? And the main thing is that it is aligned with this NCERT text only. So the chapter 9, it will direct you. It gives you the citation of this class 9th, chapter 8th, force and laws of motion, like this. This is the one thing. They can go for multiple, they can ask this thing, clear chat, just like chat GPT. So this is one of the feature. We can simply, right now I think I have to reload it. It is taking the same answer. We can type here what is electromagnetic induction. Electromagnetic induction. It is taking the same question. I don't know. Here, see. So the detail of this electromagnetic induction comes over here. What are the different key points? What is the definition of electromagnetic induction? See, this is a Faraday's law of induction, which I explained just now. Ki E equals to minus n d phi b upon dt. That is the out of the numerous experiment which Michael Faraday has done. It stated that this induced EMF in the coil is proportional to the rate of change of magnetic flux through the coil, which we expressed this thing. Okay, so this part the student will learn in the grade 12th because it is a more detailed mathematical concept. Right now I have explained demonstrate the class 10th experiment where they simply observe that what will happen if I change if there is a relative change in the motion of this bar magnet and the coil. So what exactly happening, the current is producing or not, what are the reason for that? So reason is this only, the conservation of energy, because when you are doing this at the expense of electric field or at the expense of magnetic field, current is producing.
Absolutely. And ma'am just has took a name of ChatGPT, so it's just for the reference to make you understand that Diksha is actually similar in a way that you can ask your questions there. And most important, ma'am, is this available in just one language, or you can ask Diksha in Hindi as well? In
Hindi as well. In multiple language we can use.
Okay. So in regional languages, we can use Diksha to ask our questions, our queries. That's fantastic, ma'am. And it was all about demonstration of simulation on electromagnetic induction, where we learned that where this feature is used in our daily life, and we learned the Faraday's thing, that the way he invented an important discovery by him, and most important the simulation that Uma ma'am showed us through virtual lab. And there's a Viva voice, also there
in the form of quiz.
In a form of quiz where you can evaluate yourself. 4 questions were there, and most important the learning materials that we've got through Diksha, and the whole topic explanation from there only. Thank you so much, ma'am, for this insightful session.
Thank you.
Thank you, ma'am. And this is not it. Tomorrow we'll have another virtual lab session as well, which will be all about class 8 social science subject, and the topic that we're going to cover is demonstration of simulation on formation of the union government. Of course, going to be an interesting session. You all need to stay tuned with us on NCERT official. But before we leave, I just want to tell you what we have for you on this entire day on NCERT official. Let's take a look via schedule. So after the session, we'll have a 12 p.m. session that will be based on class 3rd English subject. Topic we are going to cover is fun with friends. 12:30 p.m. to 1:15 we'll have an important session of AI in healthcare. This will be all about artificial intelligence session. At 2 p.m. we'll have class 3rd, the world around us subject, where we are going to take the topic taking charge of waste. At 2:30 p.m. we'll have class 3rd English. The topic that we're going to cover is best friends. At 3 p.m. we'll have class 4th mathematics. The chapter is the transport museum part 2. At 3:30 p.m. we'll have class 4th Urdu. The chapter is Unwan Mera Pyara Watan. 4 to 5 p.m. this will be our online training program, 1 hour online training program, where we are going to cover is AI, cyber khatre, deepfake, dhokadhadi or galat suchna. At 5 p.m. we'll end our day with a Sahyog session, where we're going to talk about building a positive relationship between student and teacher, a guide to success. Going to be an important session as well. Okay, so if you are a student of grade 4 or grade 7, so where you get your NCERT textbook, all you need to go on NCERT's official website. There you get your new textbooks, and of course on Amazon and Flipkart. So that's it for today in a virtual lab session. This is me, Neve Goswami, signing off. All you need to take care of yourself, stay happy, stay healthy, and stay tuned with NCERT official. Namaskar.